Hello, hello everyone. Hello Nitin, hello Dheeraj. Let everyone join in, then we will begin today's session. Hello Maheen. Good evening Sadiq. Hello Kirtana. So yesterday we just introduced tries, the need of the tries, their various applications. It was nice that you guys asked some questions so that you could understand where is try uh, applied, this data structure is applied, and then we were able to understand the basic understanding how try is built, right? I hope that everyone was able to understand that. Okay, let everyone join in, then we will begin. Till then, if anyone have any doubt in the yesterday's implementation, they can ask me. I have the code of yesterday's implementation. Flag 0 and flag 1. Okay, the difference between flag 0 and flag 1. Flag was basically just a Boolean uh, variable. It was used to it was used to uh, just tell us if the word that we are following in the try, if that word ends at that point or not. If the flag is one, then it's an indication that the word ends here, and if it is zero, this means the word continues. It has various applications. Uh, we will see those applications. Sometimes you need to count the number of words. Uh, I guess now my video will be visible. I apologize for the network issue on my side. Yes, good evening, Kalpana. So, I was saying, anyone have any doubt in yesterday's implementation, they can ask. Okay, good evening, Ritu. Hello, Raj. So, I was saying that if anyone has any doubt in the yesterday's implementation, they can ask. I just opened it here. Do you guys have any doubt in this? We simply first create our node. The node should have an array of pointers which should be of size 26. There is a flag for every node. What the flag does, tell if word ends here or not. Bool contains key just tells us if this try has this alphabet there or not, and put character simply adds a character to the node. Get just fetches the address of the next node, and we need a function to set our flag to false, and one function is needed to check if this is the end of any word or not, right? And then simple, we just defined our try node. We need to have a root node. We just defined a try which consists of a root node and an insert function. Insert function is pretty simple, and a search function. It was a little complicated because we need to search. It's quite similar to the insert function. If you are able to write the insert function, then you will be easily able to write the search and the find common prefix function, right? What I'm going to do is I'm going to use this for the next question I'm going to solve. The next question that we are going to solve is going to be this. Longest common prefix. I think we started with this problem, the need of the try, why we need try started with this problem, why try is needed, we use the example of longest common prefix. So just think of how you can solve this problem. You are required. Good evening, Renika. Good evening. Just try to think about this problem and tell if you can solve it in the chat. Just tell any algorithm which comes to your mind. By using loop. Okay. Yeah, makes sense. Just create pointers. Number of pointers equal to the number of words, and you can just iterate on this pointer. Longest common prefix is like the left side of the word, right? Muhammad. It's like FL, FLO, FLOW, FLOWE. These are the prefix of flower. Understood? Like this is the word. So F, FL, FLO, FLOW. This is known as prefix. And the prefix should be common between all those words. As you can see clearly, FL is common in all those, and that's the longest prefix, right? So what we're trying to solve is no Muhammad in it is not prefix, it's a suffix. Okay, so we are given an example of flower. I think I should write it a bit nicely. Flower flick, and it is given to us that the longest common prefix is FL. Moshmina, we are just trying to solve a problem longest common prefix. We can see that the longest common prefix between these is FL, right? We are trying to solve this problem where we need to output the longest common prefix, right? Okay. So one solution that we discussed was to have 3 pointers and we will iterate those pointers, right? But we know that there is another amazing we can create this type of a tree and we can clearly see that this is the longest common prefix, right? Because this is the only common branch. After this, it basically diverges, the tree diverges. This is the only common branch, right? We can see that. I hope everyone is able to see that, right? Okay. So I feel like now it's pretty simple. We first need to create a try node. We need to insert all those words, and we just need to check. We just need to check the longest word we can make till any node does not contain more than two non-null values. What I say non-null. Okay. So if we have 26 alphabets, let's say in this node A, B, C, they all will be null, right? Just F will not be null. F will not be equal to null because F is there, right? In this node. And then in this node, L will not be null, so we go to L. In this node, O and I both will not be null, both will contain some address. So whenever we find any node which contains more than one, either zero, there can be a case of zero as well, because here every entry is null because there is nothing in front of it, right? Okay, let's try and code this up. Remove this, remove this. The six flag should be equal to false. Okay, now we need to create our class of try. In this one, we will be having our node star root. Whenever we call our try, we will be having mm, node. Okay, and there should be a function which should insert a word, right? Yeah, node equal to root. There should be a function, a functionality such that which allows us to insert the word into a try. We are trying to build that functionality as of now. Node contain keyword I. So we need to have a contain key function. We simply return link ch minus a not equal to null. We should also have a put function which should be void function. I will simply do this. Okay, Now we just need two functions. One is get return and one is void with end. Now equal to true. Okay, void isn't is also something that we need. Isn't something. Okay, okay. This is the only thing which we need. Now we can simply create our help function, which will give us the prefix. Give us the prefix. Okay, so what we need? We need our answer string to store the answer. Store an node. Okay. So while true, not null values will store the not null values. Okay, so let's just if it contains the key that not null should be equal to plus plus, ch should be equal to I, right? And now if not null not equal to 1, then we should break ideally. Alright. And if flag, if node is end, then also we should break. Otherwise, simply push back the character. Get ch. Okay, I feel like this function does the job. They're initializing the answer string which are going to output. This is the dummy node which we are going to traverse, right? And now this is the node. Now we checking for non-null addresses. What does non-null addresses depict? They denote, what do they denote? They denote that that character is contained in the word which we are traversing. If at any point more than two characters addresses are not null, this means the tree diverges at that point, right? And if there is not a single not null address, this means the tree ends there. Simple as that. So if it's not equal to 1, we break. If it is equal to 1, then we push that character into our answer string because that is the common branch, and then we move ahead with the branch, right? Now we'll simply create our try node T and insert all the words and then simply call t dot help function should work. Okay, there is some issue. Oops. Again, the same mistake we did yesterday as well. Initialized a bool function with void. Contain key. Okay, what's the error? Where did I use contains? Okay, this should be contained. Okay, I think it works. I think it works. Uh, it is question number 14 of lead code, which we are solving longest count prefix. I think we can submit it, right? Just created the node and the try, and I think it will. Yes, it does work. It does work. If you guys have any doubt in this, you can ask. We just solved it using our previous implementation of try. I just use the same try class. If you guys have any doubt, you can ask. Is there any reverse try tree exists to store common postfix? Common postfix, it should be common suffix, I guess. Okay, there is no doubt to Zoe, no doubt to Bhanumati. Very nice. This means you guys are following very nicely. Even if you guys have any doubt, you can ask. I'm just appreciating. Okay, I have posted. Oops, I have posted the attendance link in the chat. You guys can mark your attendance. Cosmos, I will share the code just after today's session, I will talk to the team. What is the issue? Why you are not able to get the notes? And I'll find a way to share it. Don't worry. I guess there's a group, right, where you guys can get these resources. Till then, you will have to do the hard work. Try to see the video in order to see the code. But I'll try to find a way. Okay, so I hope that everyone has marked their attendance. Let's move on to the next problem of the day. And next problem will be a little tricky. Like, I want to firstly don't think about tries. Try to think about anything else which you can use in problem. Okay, it will be interesting. So here is the next problem. Design, add, and search words data structure. So just give me a second. Okay. Now try to think about this problem. Uh, this is uh, this is lead code website. You guys all can also. That's why I'm sharing this. Oh, that's why I'm doing the problems on lead code, right? It is open source. You can also do it. Just search for this problem number 211. You can even search the problem number 211, or even write the whole problem. I think that's too clumsy thing to do. I think you just write lead code problem number 2211, and you will be able to do the same problem, right? You can follow up. That's good you asked, because you this means like you want to follow up with me, you want to code it up with me. That's nice. Try to code it up with me, because see, if you just keep watching, and then you will not realize when you will code it by yourself where you will be stuck, right? If you will do it by yourself during the session only, then I am also here during the session. You can ask me live in the chat what's the problem you are facing. If you are not doing, just sitting idle in front of the screen, then you'll never find the gray areas where you are getting stuck, right? Okay, okay, I will write a bit slower from next time. Okay, just read this problem and give me a non-try approach. You should not use try in that approach. Try to figure out an approach which fits in. Like, for now, don't care about constraints. Just, just give me an approach. Okay, using hashing. Someone said using hashing. Okay, you can add the word and search the word. I believe hashing will not work, right? Can you just, it would have worked if this line would not be present. This line. If this line is not there in the question, then those who said hashing works, their solution is correct. But just because they said the dots can be matched with any letter, now you can't directly apply hashing, right? For example, look at this. This dot ad can also be matched with bad, with pad, with nad, with dad, with any of these words because dot can be matched to any character. Think about it. It's a little tricky. A little tricky it is. Okay, so one brute force approach. If I am sitting in an interview, one brute force approach which comes to my mind is if anytime search query comes, if add word query comes, then it's pretty simple. I can add it to an unordered set, to a set, right? But if a search query comes, I can simply check for all possible words. If there is no dot, then there is also obviously only one word possible, the word which it is, right? But if there are some dots, I can just explore all 26 raised to the power x possibilities. X is the number of dots. 26 raised to the power x. Why? Because there are 26 places which I can fill with words, which letters, and there are 26 possible letters. I can simply do recursion, check for all possible words, and check in the dictionary. If any one of them matches, I simply return true and stop my recursion, right? Yes, Nitin, stack, it kind of works. Vishwaraj says we can remove all dots first from the string. Why? I mean, the dots can be in between, right? Then there will be some problem. Okay, I believe this is a little interesting problem. So, okay, so I believe that this problem should be the homework problem for you guys. Take this as a homework problem. Try to think about this, how you can solve it. It's a very interesting problem actually. So try and think about the try approach of this. You will be amazed how try handles such things. Also this, and there will also be another approach, another problem which we'll be talking about, which is this. And now looking at this problem, it's completely amazing that try is able to solve it. But try is one of the solution for this problem, maximum XOR of two numbers in an array. Now think about this. When are we using try? Okay, when we have some limited search space, right? Let's say in case of alphabets, we just know we have 26 lowercase alphabets, right? So we use try. Okay. In in bit manipulation, we know in most cases the maximum number of bits can be 32, right? For example, if we are given that a number will always be integer, then we know that maximum bits will be 32. It kind of works like a try, right? We can kind of fit our structure of try into bits, if you can think about it, right? Um, Ritu and Aditi attendance was shared uh, before as well. I will also share it again, but here is the attendance link. Here's the attendance link, Harsh, in the chat. You can go and mark the attendance. So that's it for today's session, guys. We'll meet tomorrow, and tomorrow I have just shown you two amazing problems. We'll be solving them. Tomorrow it's going to be an amazing session. So do come, do attend. It will be really helpful for interviews, mainly for interviews because this concept is asked a lot in interviews. So do not forget to attend and don't miss the tomorrow session. I hope you guys enjoyed today's session. We'll meet tomorrow. Okay. So see you guys tomorrow at the same time, 7 p.m.